that's going to be on our next quiz. Okay? So here we go. Let's do the partial fraction problem first. Alexis said, factor the denominator. Everybody good with that? And then she said, my job is to find the two little fractions that add up to this one. Because if I had a fraction over this and a fraction over this, when I added them, I'd have to get a common denominator, and that would be my common denominator, right? So I don't know what the numerators are. I'll call them A and B. You can call them whatever you want. I wouldn't necessarily choose X because X is already down here, but anything else is fine. And then do you remember what we do, sir?
So then you would have to like multiply, like do your fraction thingy where you have to like cancel the numerators and stuff like that.
Yep, I'm going to multiply every single fraction by the common denominator. Some of you won't write this down, and I'm okay with it as long as you don't screw it up. You're multiplying every single fraction by the common denominator. Now, the reason you did that is because every denominator is going to cancel now. In this one, the whole shebang's gone. Here, that part cancels and leaves me with a times x plus 1. Here, that part cancels and leaves me with b times x plus 2. Please make sure you understand that canceling, because if you don't get that canceling right, you're not going to get the right answer. All right, is everybody okay? All right. Now, let's distribute over here. And you're not going to be able to combine any terms. There aren't any terms that are combinable over here. But let's get rid of the parentheses. Now, this is the part that sometimes we get confused on. What happens now? Sir?
You'll start doing your system of equations, so ax plus bx equals -1, and then a plus 2b equals -5.
Kids, look at the problem. On this side, we have -1x, right? That's all the x's we have, -1. On this side, we have a of them and b of them. So a and b have to combine together to give me -1. Okay, and then similarly, on this side, the constant term is -5. And on this side, the constant terms are a plus 2b. So in your equation, you're going to have things that have x's and things that don't have x's. The things with x's have to be equal on each side, and the things without x's. Now, we did do one the other day that also had x squares. Same concept. X squares have to match, x's have to match, plain numbers have to match. Okay, and then like Sir said, this is a system of equations. So you can do whatever you want with it, solve it any way you want. You know what I'm going to do? I'm going to multiply one of these guys by -1. So that when I add them, the a's will cancel. You do not have to do that. Do whatever works for you. If you want to substitute in that one, that'll work great. I would say Cramer's rule, but most of you forgot how to do that, so we need to review that. All right, and then if b is -4, then it looks like it has to be -1. I got 3. Did I make a mistake?
No, it's just, no.
I did make a mistake?
No, because I didn't calculate.
Now, listen to me. Zero in. Focus. The answer is not -4 and 3. That isn't the answer. The answer is the fractions. So A was 3, so 3 over x plus 2 plus negative 4 over x plus 1. Make the connection. You see what I just did? Now, it is extremely important, if you want to get the right answer, that when you set your problem up, you put A over x plus 2. That doesn't matter. I could have put A over x plus 1. But when I write my answer, I gotta put A over whatever I put it over. If you put 3 over x plus 1, you're gonna get the wrong answer. Understand what I'm saying? Put your A in the right spot and your B in the right spot, and all is well. Anybody have a question about that? Okay, next time I see you, you're gonna have to do something like this, okay?
Can you do how you got the two equations?
Look at the red parts. Negative 1, A and B. So negative 1 has to equal A plus B. And then negative 5 has to equal A plus 2B.
And it's because they don't have the x's.
Exactly. Okay? All right, next, let's skip down to number 9. We're running out of time here as usual. Okay, number 9. Let's just draw a triangle on our paper and label the vertices. It doesn't matter where you put them. Don't waste time plotting them. Just get a triangle drawn, call something A, B, and C, and label them accordingly. Now, does anybody remember what comes next? Izzy? We call it the directed distance. Yeah, so we're not using the old distance formula with the radical and all that. We're finding the directed distance. So we're going to find, how do you move from A to B? Do not let the notation bother you. That's vector notation. Vector is a movement. How do I get from point A to point B? Well, I have to go from 1 to negative 1. Negative 2. You got to do direction now. So pretend you're on a number line. You're walking from 1 to negative 1. Isn't that negative 2 steps? And then do the same thing. 2 to negative 3. Negative 5. On a number line. Draw it and count if you need to. Is that okay with everybody? Now, anybody, what's next?
A to C.
We have to do AC, vector AC. We're going to do the same thing, but now we're going from A to C. So 1 to 3.
2.
And 2 to 0.
Negative 2.
Everybody okay so far? Now, I always do A, B, and AC. Just habit. You could do any pair. So you could do CB and CA if you wanted, or you could do BC and BA if you wanted. It doesn't matter. You don't have to start with A. I do. All right, now what? Alexis?
It's find the determinant of the two.
So just make a determinant. Now I always recopy it because I don't want the commas and the parentheses and all that. But my determinant's gonna look like this. Okay? Now we evaluate it. You just did this on your quiz. I hope you did it well, or I did it on the last quiz, I guess. So that's gonna be 4 minus negative 10. 4 minus negative 10. Right? Which is what? 14. And then the last step is?
Divide by 2.
Divide by 2. Anytime you're finding the area of a triangle, there's a half involved somewhere. And in this case, it's at the end. So the area is 7. Okay? All right, one more problem. One more problem. All right, any question about this before I erase it? Okay, the last one isn't on this sheet, so you probably aren't going to do any more of this sheet, so you can squeeze it somewhere on that sheet if you want. Oh, no, we gotta do this, folks, here we go. So I'm just gonna make one up, x plus 2y equals 7, 3x minus 5y equals 2. There you go. And the directions are going to say, solve using Cramer's rule. So it was your bonus today, it's gonna be a required question tomorrow. Okay? Solve using Cramer's rule. Here we go. What's the first step, Alexis?
You gotta do the one and 2 and be negative
The
5.
determinant of the coefficients. Come on, guys, we can get this done in a snap. This is easy. We find the determinant of the coefficients. So these are my x's and y's. And I evaluate that. So that will be
-11.
-5 minus 6, -11. Now, just like with our linear programming problem, when you find where two lines cross, it's an ordered pair. Remember, we had to find those 3 points? So we're finding where these cross. It's going to be an ordered pair, and this time the answers are going to be fractions over -11. That's what the coefficient determinant does. It gives you your denominator of your solutions. All right, Izzy? No? Okay, sir?
Now, won't you have to do like, would you have to like move the, like do negative, like switch the, or do you just put the answers into the, like X and Y?
Okay, I'm not sure what he said there.
Oh.
Here's what we're gonna do. Oh, yeah,
For X to use 7 and 2 and then 2 and
exactly. Cut out the 7 and the 2. Cut this out. If you're solving for X, paste the 7 and the 2 in the X column. So that determinant looks like this. If you're solving for Y, hey Ben, if you're solving for Y, then we cut out the 7 and the 2 and paste it in the Y column. And then you evaluate those determinants. So this will be -35 minus 4, -39, and 2 minus 21, -19. So our answer, we gotta get rid of those negatives. Also, always reduce if you can. Obviously, you can't reduce in this problem, but we can get rid of the negatives, and that's your answer. So next time I see you, we'll have another quiz, because I just love to grade papers, and you just love to take quizzes.